Hello everyone. So today we are going to discuss a question from the JEE Advanced 2026 paper 2, and it is from the electrochemistry topic. And what is it here? It is said is at 300 Kelvin the molar conductivities of the aqueous solution of three salts at two different concentrations are given below. These are the values. If you see here, three types of salts are given: NaNO3, NaCl, and AgNO3. And these salts have the different concentrations. At different concentrations, the molar conductivities are given. Two types of concentrations are given: 0.01 and 0.04. Conductivity of a saturated aqueous solution of AgCl is 1.40 into 10 raised to the minus 6 Siemens per centimeter at 300 Kelvin. If the solubility of AgCl in water at 300 Kelvin is x mole per liter, then log 10 x raised to the power minus 1 is. And we have to assume that the AgCl dissolved in the water ionizes completely, and that the molar conductivities of the saturated AgCl solution is equal to its limiting molar conductivity. So we have to tell the answer, and the C option should be the correct answer. How to do it? I have solved the question. So what we have to do, but first we have to take the salt first, NaNO3. For NaNO3, when the concentration is 0.01, we can use this equation. This equation is known as the Debye-Huckel-Onsager equation. Debye-Huckel-Onsager equation, which applies for only strong electrolytes, and we know that the NaNO3 is a strong electrolyte. From this equation, and lambda m equals to lambda m naught minus A 10 raised to power minus 2, which is the concentration, 0.01 raised to power half. So we can calculate A from this equation. And similarly, for C equals to 0.04, we can use this same equation by putting the concentration 0.04. We get the value of A. We have two equation number 1 and equation number 2. And by equating these two equations, equation number 1 and equation number 2, we get the value of lambda m naught for the NaNO3. Then in the next, we take the NaCl salt. For the NaCl salt, we have two concentrations, concentration 0.01 and 0.04. Values for these concentrations for lambda m is given. We use those two values, and we have two type of equation 3 and equation 4. Similarly, as we have calculated for the NaNO3. So we get these two equations, and by equating these two equations, we get the lambda m naught for the NaCl. Similarly, we use for the AgNO3, two concentrations, two values of A, and by equating these two equations, we get the lambda m naught for the AgNO3. And these are the three values we get for the different three salts given in the question. And now we use the Kohlrausch's law of independent migration of ions, which says that the lambda m naught of AgCl will be lambda m naught of AgBr, AgNO3 plus lambda m naught of NaCl minus lambda m naught of NaNO3. And by using those values, what we have calculated, those three values, we put it here, and we get the lambda m naught of AgCl, which is 140. So from this question, we know that the lambda m naught of AgCl is equals to lambda m naught of C AgCl. It is given in the question that the limiting molar conductivity of the AgCl is equals to the molar conductivity of the AgCl at a saturation. So that's why we have equated it. And also AgCl ionizes completely, so we can apply this equation, and from this equation tells us about the concentration of the solution, or we can also say the solubility of the AgCl. So when we calculate m from here, we get the 10 raised to the power minus 5, which is also x, value of x. And when we use log 10 raised to, we have to calculate log 10 of x raised to the power minus 1, and when we put the value of x here, we get the log 10 x raised to the power minus 1 as 5. So that's why the option number 3rd or C is the correct answer. 5th option will be the correct answer. 5 will be the correct answer. Okay, thank you so much for listening.